Hello friends. So after covering a numerical on Laplace transform derivative, let's move ahead with one more numerical where we are going to solve the differential equation with the help of Laplace transform. So here we have to solve dy by dt plus 2y plus integral from 0 to t y dt equal to sin t. It means we have to solve the differential equation and get the value of y as a function of t, because it is in this given differential equation y is a dependent variable on t and t is an independent variable. It means our final answer is gonna be y in terms of t. So guys, there are many methods to solve the differential equation, but since we are in Laplace transform, we have to use the method of Laplace transform to get the answer of differential equation or the solution of differential equation. And guys, let me tell you that to solve this type of question, we have set of steps. So step number one is apply Laplace transform on both sides. So here I'll say, so this will become, so here I have applied the Laplace transform on each and every term separately. Now guys, let's find out the Laplace transform of each and every term. So here the first term is dy by dt. So here I can say that if y is a function of t, then dy by dt is nothing but the derivative of y, which is nothing but y dash of t. So it means I have to find out the Laplace transform of y dash of t. Now guys, how to get the Laplace transform of derivative? And for that reason I am going to use the property of Laplace transform of derivative. So here is the formula. You can see that in the formula number 1 we have Laplace transform y dash of t, which is given by the formula s into Laplace of y minus y of 0. So guys, here we will get s into Laplace of y minus y of 0 plus 2 times Laplace of y is as it is. Next, what is Laplace transform of this? So guys, here if you see the function carefully, there is an integration from 0 to t, and it is again our one of the property which is called as Laplace transform of integral. So let me show you that also. So according to the property of Laplace transform of integral, if it is integration from 0 to t, we solve it by this property, where the answer is given as 1 upon s phi of s, and where phi of s is Laplace of this f of u. So here our answer for this property will be 1 upon s. Here I'll write down 1 upon s into phi of s, and as I told you that phi of s is nothing but the Laplace transform of this function of u or function of t. Now here our function is y, so that is nothing but Laplace of y. And guys, Laplace of sin t, it's a standard formula. It is 1 upon s square plus 1. So now let's simplify all these given values, and let's take this Laplace of y terms together. So here we have s into Laplace of y plus 2 into Laplace of y plus 1 upon s Laplace of y. I can take Laplace of y common. So here we will get s plus 2 plus 1 upon s into Laplace of y. And the value of y of 0 is 1. So I can put it here, which will become minus 1. So minus 1 I can shift to right hand side, and that will become 1 upon s square plus 1 plus 1. So that negative 1 has become positive 1. Now guys, let's simplify this. So here I'll do the cross multiplication, and here also I'll take the LCM. So here LCM will be s, and we'll get s square plus 2s plus 1. So s square plus 2s plus 1 upon s into Laplace of y is equal to, here by cross multiplication we can get s square plus 1, that is s square plus 2. So s square plus 2 upon s square plus 1. Now guys, this is nothing but s plus 1 the whole square. So I'll send it here on the right hand side. That will go in the denominator and s will go in the numerator. So we will get Laplace of y equal to s into s square plus 2 whole upon s square plus 1, this term, and this will come in the denominator, which is nothing but s plus 1 the whole square. And guys, here we got the value of Laplace of y. Now the question is, we have to solve this differential equation. It means we have to find out the value of y and not of the Laplace of y. So to get the value of y, I have to shift this Laplace or L on the right hand side. So which will become L inverse on right hand side. It means y is Laplace inverse of s into s square plus 2 upon s plus 1 the whole square into s square plus 1, and I'll call this as equation number 1. So it means guys, now we have to find out the inverse Laplace transform of this function of s to get the value of y. And to get the inverse Laplace transform of this, here we have to use the method of partial fraction, because by using that we can separate this big function into small functions, and then we can apply the linearity property of inverse Laplace transform. So now guys, what is the partial fraction of this function? So I'm sure that you have practiced the partial fraction in the lower standards, where I'm going to use the same concepts over here. So here I'll say by partial fraction, so this will be now guys, here this first term is s plus 1 the whole square, which is the linear factor, but it's a repeated factor. So for that, what do? We use the constant in the numerator, so that will become a upon s plus 1 plus b upon s plus 1 square. So since this factor is been repeated for the 2 times, I'm writing it for the 2 times. Now the third factor is a quadratic factor, so that will become cs plus d in the numerator, because we know that whenever we have a quadratic factor in the partial fraction, we write down the numerator as linear factor. And guys, after this we are gonna find out the value of a, b, c, d, and we'll put it here. So let's call this as equation number 2, and let's find out the value of a, b, c, d, and let's substitute over here. So for that reason, I have to take LCM on right hand side. So what is the LCM of RHS? So here, if you see the denominator, that it will be s plus 1 the whole square into s square plus 1. Now we'll bring this denominator over here, or we'll make the changes in this a, b, c, s plus d, this numerators accordingly. So for that, what I'll do is, since this is the LCM, I'll multiply this term by s plus 1, so that I can get s plus 1 square and s square plus 1, and with the same terms I'll multiply in the numerator. So here we will get a into s plus 1 into s square plus 1. Now for b, we already have s plus 1 the whole square, so I'll multiply with s square plus 1, and here also s square plus 1, so plus b into s square plus 1. Here in this denominator we have s square plus 1, I don't have s plus 1 the whole square, I'll multiply here as well as in the numerator. So we will get plus cs plus d into s plus 1 the whole square whole upon, will get these terms. So these 2 terms will be cancelled with these 2 terms, and this numerator I'll write down there, which is s into s square plus 2. So guys, I'm sure that you understood how to get the LCM. And now next part is, let's find out ABCD by substituting different values of s. So that is one of the method, and the other method is comparison of coefficients. So these are the two methods to get the values of a, b, c, d. So let's start. So here I'll put the value of s as -1 so that this denominator will become 0 and we can get the value of a. So s plus 1 is 0. We all know that whenever we want to find out the value of a, we treat this denominator as 0. So I'll treat s plus 1 as 0 and that becomes s equal to -1. So I'll put s equal to -1 in equation here in equation number 3 and we'll find out the value of constant. So here I'll say put s equal to -1 in equation number 3. So guys, this will give us -1 square 1, 1 plus 2 3 into -1, so -3 equal to, here -1 plus 1, so this is 0, -1 square 1, 1 plus 1 2, so that becomes 2b, here -1 plus 1 0, this is 0. So it means the value of b is -3 upon 2. Now let's find out the value of b, c and d. Now denominator of b is exactly same, that is s plus 1, and guys here we got the value of b only. So it means since these two denominators are exactly same, we got the value of b when we put s equal to -1. So to get the value of c and d, if we make this denominator as 0, we get s equal to imaginary number. We should not put imaginary number over here because we will get answer as imaginary. So what we'll do is we'll put any value of s to get the value of a, c and d. So guys, here I'll put s equal to 0. So here I'll say put s equal to 0 in equation number 3. So this will give us left hand side as 0, where s is 0. Here 0 plus 1 1, 0 plus 1 1. So 1 into a, that is a. S is 0, 0 plus 1 1 and b is -3 by 2. So -3 upon 2 into 1 is -3 upon 2. Then s is 1, s is 0. So this will become 1. S is 0. So this term will become 0 and here we'll get d. So it means guys, here we will get a plus d is equal to 3 upon 2 and I'll call this as equation number 4. So now guys, we are gonna get the linear equation, or I would say the simultaneous equation, and we are gonna solve simultaneous equation to find out the a, c and d. Now let's put next value of s. So we'll put s equal to 1 because we already taken -1 and 0. So I'll say put s equal to 1 in equation number 3. So this will give us 1 plus 2 3 into 1, that is 3. Next 1 plus 1 2, 1 plus 1 2. So 2 into 2 4, 4a. Next 1 plus 1 2, 2b, and b is -3 by 2. 2 to cancel, so I'll get -3. Here 1, so c plus d as it is, and 1 plus 1 2, 2 square is 4. So 4 into c plus d will give us plus 4c plus 4d. So if I take 3 here, that will become plus 3, which is 6. So I'll get the equation 4a plus 4c plus 4d is equal to 6, which is equation number 5. Now let's put one more value of s in equation number 3 to get one more equation, because we have to find out the three equations. We have to find out the three unknowns, that is a, c and d, and hence we require three different equations. So now let's put some different values. So I've already put this -1 0 and 1. So now I'll put s equal to 2. So here I'll say put s equal to 2 in equation number 3. So this will give us 3 square, s is 2, so 2 square, which is 4, 4 plus 2, 6, and 6 into 2, that is 12. So LHS is 12, equal to, here we'll get 2 plus 1 3, 2 square, that is 4, 4 plus 1, that is 5. So 3 into 5, 15a. Next 2 square 4, 4 plus 1 5, so 5b. And guys, value of b is -3 by 2. So -3 by 2 into 5, it is -15 upon 2. Next s is 2, so that will become plus 2c plus d, and here we will get 2 plus 1 3 and 3 square is 9. so into 9. Let's simplify this. Here we will get 12 equal to, or this can be shifted to LHS, that will become positive 15 upon 2. Next 15a, this is 2c into 9, that is plus 18c, and this will become plus 9d. Now this is nothing but 24 plus 15, that is 39. So 39 upon 2 equals to 15a plus 18c plus 9d. Now guys, if you want, we can reduce it by taking 3 common. So from here, if we take 3 common, here we get 13 upon 2. Here we'll get 5a, here we'll get 6c, and here we'll get 3d. Similarly, from here we'll take 3 common, so we'll get 13 upon 2 only. And we will call this as equation number 6. Now we will solve equation number 6, 5 and 4 in the calculator, so that we can get the value of A, C and D. So guys, by solving these 3 equations in Cal C, we will get value of A as 1, then value of C as 0, and the value of D as 1 by 2. So here we got value of A, C and D. So now we will substitute these 3 values of A, B, C, D. So these are nothing but the capital A, C and D. So here we can say that this is A equal to 1, this is C equal to 0, and capital D equal to half, because we have considered the name of the constants as capital A, B, C, D. Now guys, we got the value of A, B, C and D. We'll put all these values in here equation number 2. So let's see what we get from 2. So I'll put A over here. So the value of A is 1. So this will be 1 upon S plus 1. So I'll say therefore from equation number 2 we'll get now guys, the next term is B upon S plus 1 the whole square, where value of B we got is minus 3 by 2. So here I'll substitute B as minus 3 upon 2. So we will get minus 3 by 2 into S plus 1 the whole square. Next, here I'll put the value of C and D. So we got C as 0 and D as half. So this will be 0, here I'll get half. So plus 1 by 2 S square plus 1. So here we got the partial fraction of this given term. Now guys, I'll put this partial fraction or these 3 fractions here in the equation number 1, so that we can find out inverse Laplace transform of that given function. So here I'll say therefore y is equal to inverse Laplace transform of 1 upon S plus 1, and then now inverse Laplace transform of this 1 upon S plus 1 is e to the power minus t. Next, in the second term I'll take minus 3 upon 2 outside, and we'll find out inverse Laplace transform of 1 upon S plus 1 the whole square. Now guys, here we are going to use the shifting theorem, because here this is a function of S plus 1. So that will become e to the power minus t into inverse Laplace transform of 1 upon S square. And then here half as it is, and inverse Laplace transform of 1 upon S square plus 1 is sine of t. Now guys, the inverse Laplace transform of 1 upon S square is t. So we will get e to the power minus t minus 3 by 2 e to the power minus t into t plus half into sine t. And guys, this is nothing but inverse Laplace transform of given function. So here this was the given differential equation, and we got the value of y in terms of t. You can see here value of y in terms of t by using the inverse Laplace transform or Laplace transform concept. So I'm sure that you understood this video how I got the solution of the differential equation. And if you want to learn more videos on engineering mathematics and Laplace transform, then keep watching videos and keep following everything on YouTube as well as ekeeda.com. Thank you very much.